Ever feel like your dev team is stuck waiting on builds with every developer redoing the same builds? Hours are wasted and productivity drops. In this DevZero powered video, I'll show you how a shared Bazel build farm on Kubernetes enables caching across developers. So each build is faster and no one's waiting around. Stick around to see how to make every build faster for your team. Here we go. We're in the DevZero console and we have one workspace running in this cluster with this ID here. And really this workspace is hosting our Bazel build farm. It's running in Kubernetes as a Helm release and waiting for us to work with it and send some builds to it. So the first thing we're going to do is we're going to create a new workspace. And let's say that I'm developer one. So we'll call this dev A, for example. So my workspace is dev A. I'm going to select the recipe and we're developing in Golang. So here's my Golang recipe. Let's select that. And then we have a cluster to choose from. We have three. I'm going to use the all users cluster, right? And then launch. Now let's take a close look at the recipe. It's a simple recipe. Great, bringing in a few packages that we're going to use. A simple command here, as you can see, for Go. So we're deploying our Golang environment, getting it ready. Then we're installing Bazel. And then we're creating a simple Go application. As you can see, it's just going to print hello world. And then we're creating a build file. And this is the content of the build file, very simple. And then we have a workspace file. And this allows us to use the toolkit in the remote environment. So we're going to use it from our local environment to reference that remote build farm. And finally, here we have a Bazel RC. And this is basically a configuration file to get Bazel to talk to our remote environment here. You can see this is the workspace that we're running the build farm in. So that's going to get issued whenever we're running the build command. You'll see the Bazel build or Bazel run command. And finally, we have an update welcome message so that we can tell people what to do when a developer issues or starts a new workspace. They'll know what to expect. Okay. So let's go back to our workspace, see if it's ready to go here. It looks like it is running and ready to go. So let's open that. We'll open a terminal window here. Let's make this bigger. And here's our welcome message. You can see to get started in this workspace, you can either run build with Bazel, Bazel build main, or build and run Bazel run main. So let's grab Bazel run main here. We gotta right click this and copy and then paste that. And there we go. This took about 28 seconds. And now if you run it again, it will go very quickly because it's going to reference a local cache. Now let's notice a few things here. You can see 10 processes, 4 remote cache hits, 6 internal. I've run this before and therefore the build server already has cached a few things here. That's why we see some hits. And of course, when we run it again down, the time is much shorter, 0.624 seconds. And one process, one internal hit, you can see no remote cache hit because we're now using our local cache. And both times we're, of course, getting the result, hello world. All right, so this looks really good and can continue to develop as user A, but now developer B wants to come in and work on our same code on the same application. So then they can launch a new workspace, B, and select the same recipe, Go recipe. Let's select that. And we'll select that same cluster for all users. We'll launch that. All right, the workspace is running. Let's go ahead and open a terminal window for our developer B. Make it bigger. Of course, we get the same thing as we saw in developer A because it's the same recipe. So if we cleared out of here, and once again, if I show you actually ls, you'll see all the expected files that we saw before. So you can see the Bazel RC is dropped in here as we specified in the recipe. We got the build, the workspace, the main.go. Now let's go ahead and run Bazel run main. The first time we run this, of course, is going to take a little bit of time, just like user A when we saw dev A running it. All right. Took about 38 seconds. Well, if we go and run it again, now it took much less because it's working from local cache. And once again, we see the 4 remote cache hit as well. But let's do something. Let's go ahead and change something in the main.go application so we can recompile. And let's say update, or just say from B. All right, we see that we've made the change in main.go. Let's go ahead and rebuild. Now, as you see, we've rebuilt 3 processes, 1 internal and 2 remote. If we do the exact same thing on user A, so if I go and open here and say from B, and let's go ahead and run Bazel, run main again. Now we see that we have a remote cache hit right here because we are leveraging the build that user B has built because we're building the exact same thing. Of course, you're going to be running with Git. I'm just simulating this in a very simple fashion. Another developer will be pulling the entire code with Git, cloning it, for example, in their own workspace, and rebuilding will leverage whatever has been built before in our build farm, and you'll see the remote cache hit here. That's really what we're trying to show, that you can have a centralized build farm and get your developers to easily get started with whatever programming language you're working with. In this case, we're working with Go, but you can, of course, extend this to any programming language and have that same Bazel build farm for multiple languages, for multiple developers, and speed up the development process and the compiling and building time. Thanks for watching.